We're taking a look here at how Cisco routers create interface identifiers and where we're getting the second half of our link local address from in a very simple process. The router takes the interface's MAC address, chops it in half, technical term, sticks FFFE in the middle, and then performs one little innocent bit inversion. Done! And you might be thinking, that sounds simple until we got to that last part with that bit inversion. That's actually going to be the simplest part of the process. This entire process is simple, and it's a great thing to know for your exam. Now, let's see what this process is all about. First, with a walkthrough, we'll use the MAC address 112233 AABBCC, and we'll chop that in half and insert FFFE. And we're almost done right there. We've got 112233FF, FAAA, BBCC, and we are almost done creating our interface identifier. Now, what about that bit inversion? This is a big city, fancy schmancy way of saying if it's a 0, make it a 1. If it's a 1, make it a 0. Not hard at all, right? I mean, you're just changing one bit to the only other possible value that it can have. Now, we need to convert the first two values into a binary string, and both of them are 1s in this case since we started with 1122. So we're starting with 11. You just convert those to binary and you invert the 7th bit. And this is it. You know, the first one is going to be 0001, obviously, and those are bits 1 through 4. The value that follows it also happens to be a 1 in our walkthrough. That's also going to be 0001, and those are bits 5 through 8. So what do? We take that 7th bit, which is always going to be the 2 value in the second number, in the second hex value, and we just change it to its only other possible value, which just happens to be 1. So there's nothing to it. You just did the bit inversion. Now the string to begin with was 0001, 0001. You invert that 7th bit, we get 0001, 0011, and the result is 1, 3, because the 2 and the 1 bits are now set for the second value. All you do is replace the first 2 characters with the ones you just came up with, and you're done. And our interface identifier is shown on the screen, and now it begins with 1322. Now, some of you are saying, why am I even bothering to convert the first character, first hex value, if I'm not changing anything? You don't have to. If you're comfortable with just grabbing the second value and changing the 3rd bit in it, you're fine. So in this case, you could have just looked at the 11 here on this screen and said, okay, I'm just going to break that second value down and invert the 3rd bit. The reason that I want you to get used to doing it the slightly longer way is it helps you remember that you're inverting the 7th bit. Okay, so this is all you got to do. Write out those first 2 values in binary. It's a good little practice while you're at it. Invert it, and you are done. Now, that theory sounds fantastic, but does it match reality? We're going to find out by using the MAC address on Router 2's fast Ethernet interface. We're going to manually determine the interface identifier and then see if it matches up with what the router's already come up with. So let's go ahead and do that thing. We got Router 2 right here. I've got show IPv6 interface fast Ethernet 0/0. The link local address, the interface identifier part is highlighted. Where can I get the MAC address from in this command? Nowhere, because it is not there. So if we can't find it there, we'll find it elsewhere. And now it's hard not to put v6 in there. Let's do show IP interface fast 0/0. And why are we getting this information? Why is Internet Protocol Processing disabled? That sounds pretty bad. Well, what it means, of course, is IP version 4 processing is disabled. So let's go just show interface fast Ethernet 0/0. Always go back to the basics when in doubt, and there is our MAC address on the second line of output. And the BIA there is burned in address, and usually these 2 values are going to be the same. The only time you'll see something different here is if someone has actually changed the MAC address on the interface, which is rare. So there's what we're beginning with, 001B D4C2 0990. So knowing what you know, go ahead and stop the video and come up with what you think the interface identifier is. And you're going to need to pause the video because I'm going to rock and roll and keep moving. We chop that address in half, put in FFFE, and that gives us 001B D4FF FEC2 0990. First 2 characters there, first 2 hex values are 00. We know what converting those to binary is. I wrote it out for you anyway, but it's all zeros. So if we invert the overall 7th bit, that gives us 00000010, which is going to convert back to 02, because that second value is made up of 0010. We know that's the 2-bit that is set. We then replace the original 00 at the front of that address with 02, and what do we get? 021B, etc., etc. Now, that looks pretty good, but we also know there's going to be some compression involved here. So what would that compress down to? We drop a little leading 0 compression on that bad boy, and we get 21B, D4FF, FEC2, 990. Does that match the interface identifier portion of the version 6 address? Well, let's find out. Actually, we can just scroll up. I don't even need to run the command again. And we get 21B, D4FF, FEC2, 990, and that's exactly what we have up there on the board. So fantastic stuff there. You now know how the router came up with it. Should you be asked on the exam to manually come up with one on your own, you can certainly do that. But that's how we get that second part of the link local address. And let me go ahead and bring that back up. We're down on the version 4 info. And you can see here's the entire link local address, and now we know exactly how that was arrived at. There's another use for the interface identifier, and that's as part of the global unicast address, I believe. And we're going to see how that works at the beginning of the very next video. See you there.